In today's video, we'll learn how to deal with basic file input and output, or file I/O. And as you will learn, file I/O is useful for reading data from a file, writing data to a file, but the Java I/O library is so much more powerful than that. We all know what a stream is. A stream is a body of water where things float down the stream from one location to the other. In computer science, we also use the word stream to designate a flow of data from one location to the other. And once that data has flown past the point of capture, it's gone. Imagine system.out.println and imagine printing out hello. Well, first the H will be here, and then the H will move down the stream, and then the E, and the E will move down the stream, L, L, O. And these characters just move along the stream until the flow of characters is done. Just like in system.out.println, which uses a stream, you can't go back and print the previous character. Once the character has been sent to the buffer, once it's been sent to the console, the character is there, but the character can no longer be recovered. That's why you can't have a function like system.out.repeat the last string. Look at these classes from the Java I/O library. The first thing you'll notice is there's quite a lot of them. There are many different classes in this library, and for you to fully understand input and output, it's best for you to review the entire library and see what each of the classes do. In this particular lesson, we're going to cover basic file I/O, so we'll only use a few of these classes. It is hard at first to understand the Java I/O library, but one of the first things you can do is to learn to distinguish the difference between the classes that are byte-based versus the classes that are character-based. Let's give an example. Here is a 5. If I were to store 5 as an integer or as a byte, I would store it this way. It's got 1, 1, it has 0, 2s, it has 1, 4. In this way, 5 is stored mathematically, and it's stored as a byte. But 5 is not always a number with numerical significance. It can sometimes act just like a letter or another character. Consider the band Maroon 5. If I was to store Maroon 5, this would be a string, and 5 would just be a character. It would have no mathematical meaning. In this case, 5 would be stored as a character. And in order to do this, we have to leverage something called the ASCII character set. Every character that we type on a keyboard has a numerical value to it. So for example, here we see that the character 5 from the ASCII character set is represented by the decimal value 53. And so therefore, it's very important to determine when you're doing file I/O, are you working with characters or are you working with bytes? So if you had a text file that was created using a text editor on Linux or created using Notepad, you would simply be storing all the characters of that file. However, if you were to have a Word document, even if all you type were characters, that Word document would be byte-based, because in Microsoft Word, they have special controls for things like boldface type or underline type. So it would not be character-based. If you had an HTML file, that HTML file would be character-based. If you had a Java source program, the source code is also character-based. But the bytecode from Java is byte-based. So you can see your first most important decision is to identify what kind of input or output you have. Is it in fact byte-based or is it character-based? And this handy chart shows you different types of classes in the Java file I/O library and how they would be used. So for example, in the green column we have the purpose. If you're working with files, you might be working with file readers and file writers, if you're character-based. But if you're not character-based, You will probably work with things like file input streams or file output streams. But not everything in Java File I/O is files. You could work with simply reading arrays or outputting arrays. And you can use the File I/O library. There are classes to deal with arrays. You could also look at something like pipes. Pipes will send data from one process to another. You can also look at things like strings. You can do parsing with the library. You can filter with the library. You can write out objects with the library. So again, decision one is, are you byte-based or are you character-based? And then decision two is, what's your purpose? What kinds of data are you dealing with? Another thing to take note of is that for the byte-based and the character-based classes, some are used for input, some are used for output. And this is true on both sides. It is very rare that the same Java File I/O class is used for both input and output. One of the exceptions is a random access file. A random access file will be used to read from different parts of the file. Generally, the File I/O classes start at the beginning and they end at the end. That's how they read, that's how they write. But if you wanted to move into a different section of the file and not begin at the beginning, you would want to have random access. And that's one of the few cases where the classes are exactly the same. But as you note, in most cases, they're different. The other thing to be aware of is this generic form or the superclass. We know what superclasses are, and above this line are the superclasses. And very frequently, just like you would with collections, you will declare your variable with a superclass, but you will instantiate it with a subclass. Just like in collections, you should use this technique if you are comfortable at using only the methods of the superclass. In this way, you can switch the implementations by instantiating the superclass variable with one of the different subtypes. And this area here is a list of some of those subclasses you could use. Also, one last thing to pay attention to, in the character-based side, there are reader and writer. Those are the highest level classes, but they're abstract classes. So obviously, we would not be able to instantiate instances of reader or writer. So input and output typically works coming from a source into your program where you can read, and then as output from your program after you massage or do something with it when you write. There are different elements that can act as either the source of data or the destination of data. Some of those are called standard streams. Java has 3 standard streams. The first is system.in, which you may recognize from when you use scanners. When you make a scanner, you have to pass it an input stream, and you actually pass it in system.in to read from the console. There is also the familiar system.out, used in system.out.println. System.out is the stream you use to send information to the console when you're writing in Java. But you can also send information from system.out elsewhere. We'll learn about that later. And you've also seen system.er. System.er, you're mostly familiar with it by looking at the red text that comes back when you have errors. When you have errors, the Java compiler will send the error messages to system.er, so you can see them in a different color than system.out. They're typically red. So these are known as the 3 standard streams of Java: system.in, system.out, system.er. As expected, you can also read from an input file, and you can also write out to an output file. You can also read from a buffer. A buffer would store information in memory in the computer for faster reading. You could read from the buffer. You could write to the buffer. And finally, the last two types of sources and destination. You can read data directly over a network, and you can write it to a network using a network connection. And you can also use pipes. Pipes will allow processes to exchange information, to read information from another process, or to write information destined for a different process. So these are the different types of sources and destinations. So as we said at the onset, the I/O library can do many different things. File access, enable network access, buffer access, pipes. You can do filtering, parsing, reading and writing text, reading and writing primitive data, working with arrays. There's quite a bit to do with the file I/O library. In future videos, we'll begin to explore some code that will actually do some file I/O. Thanks again. I hope you found this information interesting and useful.